Okay, so for this one, we have limit as x is approaching infinity of another kind of strange equation. We got the square root of x squared plus 6x and then minus x. Oh, and then we're going to put that all over 1 so we can kind of just work with this a little bit. And then we're going to multiply this whole thing by the reciprocal of the numerator so that we're going to hopefully cancel some things and make that top numerator a lot easier to work with. So when you do all that, you get the limit of this function as x is approaching infinity of x squared plus 6x minus x squared. So that's good because you're going to have the x squared and the negative x squared cancel out, and you're just going to get 6x. So then you got to figure out what you're going to do with the bottom. You got the square root of x squared plus 6x plus an x. So what you could just look at that and say, okay, we got infinity over infinity plus infinity, and that's not going to work. We still got infinities on the bottom. So you go back to what we've been doing before, multiply again by 1, except this version of 1 is going to be 1 over x, and that's going to simplify things for us and make it so that we have the limit as x is approaching infinity of 6 over the square root of 1 plus 6 over x plus 1, and then you do your simple limits. We made this easy for ourselves. We got 6 over 1 plus 1 equals 3. And now this one is a little bit different. We got to make a piecewise function out of f of x equals the absolute value of x plus 5 over 3x plus 15. So when you look at this, you notice you're going to have like a problem when you have negative 5 in here, because you get negative 5 plus 5, the absolute value of 0 is just 0. And then you have 3 times negative 5, which is negative 15 plus 15. You got 0 over 0. So that's an issue. You know that negative 5 is going to be an important value. So when you look at that, you can kind of cancel stuff. You can pull a 3 out of the 3x plus 15, so you get a 3 times x plus 5, and you can cancel out the x plus 5 over x plus 5 and get 1/3. So what we just showed there was that x is going to equal 1/3 when x is greater than negative 5, because we took a positive value for the numerator. But then when you take a negative value for that, because it's an absolute value, you're going to have a negative x plus 5 over 3 times x plus 5, and you're going to get a negative 1/3. So when x is less than negative 5, you have that negative 1/3 value. And then it asks us to find the limit of f of x as it's approaching negative 5. And what we just showed in the piecewise is that we have two different things when x is negative 5. We can either have a 1/3 or a negative 1/3. From the different sides, it's approaching different things. So that's just going to be does not exist, because if it's approaching two different things, there's no set limit, and that's your answer.
Here's the last problem for the 2.3 notes. It's a piecewise function of f of x equals, you got the x squared minus 15 if x is less than 4, and the absolute value of x minus 4 over 2x minus 8 if x is greater than 4. What you're going to want to do first off is just plug in the 4 for all of it, and then for your first equation you just have a 16 minus 15, and that's going to get your limit as x approaches 4 from the left, and that's going to get you 1. And then for your other one, you have a slight problem, because when you plug in 4, you're going to get a 0 over 0. So what you do is you're going to take out a 2 from the bottom, from the denominator, and then that's going to get you an x minus 4. And so what we did on the other problem is basically the same concept with that. You're going to get a 1/2 with that, and then that's just going to be your limit as x approaches 4 from the right. And then you're asked to find the limit as x approaches 4, and that doesn't exist because they both equal different things as they approach 4 from different sides. So that's why your answer does not exist.